My name is Dr. Patrick Kwabena Mensah, and I'm a senior lecturer at the Department of Computer Science and Informatics, University of Energy and Natural Resources. So we basically do research here, and this project, I'm the principal investigator, and what I do basically is to coordinate the activities of the project here. Again, in addition to the fact that I'm a principal investigator, I I'm also part of the team that developed the models and tested them, and then the deployment of mobile phones. The app works in a very simple way. It is a mobile app and a web app at the same time. So if you have it on your phone, when you launch the app, it gives you three tabs. The first one is if you want to use it in an English version. If you want to use the Akan or Chi version, which is a local language, it's about 90% of Ghanaians speak that language. If you want to use that version, you can also pick the Chi version. And again, if you want to use the app, the web app version, you can also pick it on the phone, on the same app. So, assuming that you choose the English version, then it will open a new window for you where you have two tabs. So, the first one, you click on it, it opens the phone camera, and then you snap the image of the plant. As soon as you snap the image of the plant, then the app automatically detects the disease for you. Again, if you already have the image on your phone, what you do is that you click on the gallery button, which again opens your phone gallery. You pick the image you want, and then the app does the automatic detection for you. So we try to make it as simple as possible because it is the farmers who are using it, and most of them are not literates. Again, you can control the app with voice. We have added conversational AI that when you just mention the name, so for instance, you want to open the cassava app, you just mention cassava, and then it will automatically open for you. We did this to help the disabled and those who cannot actually see and read. Now, when we come to the Google Colab, you know, training of deep learning models goes or comes along with carbon emission. So, in order to avoid a lot of carbon emission that the training was going to give on our local GPU machine, we decided to train on Google Colab. And actually, when we compared the carbon footprint of the Google Colab training and that on a local machine, we realized that the Google Colab emitted a small number of carbon compared to our GPU. So that is the role that Google Colab played for us. We have considered the fact that internet connectivity, especially here, is very, very difficult. So you go to some remote areas and the internet is not there at all. Because of that, we designed or developed the app in such a way that it does not require the use of internet. So if you launch the Tree app, everything is on the app. The models are already trained. So what you need is the image for testing, and you do that on the mobile phone. So it requires no internet. The only aspect that requires the internet is when the app does a detection and then determines that the confidence of detection is not up to 100%. Then it would recommend to you that send this image to, we have three consultants, send this image to one of the consultants to check for you whether it is actually what the app detected. And in using either WhatsApp or email to send that image, you would require an internet. So that's the only aspect of the app that you require internet. As to how we want to make, we'll be able to make it accessible to the farmers. The first thing is we started the whole project by involving the farmers in the first stage. So we went for stakeholder engagement, and then we sold our idea to the farmers and the other stakeholders. Then we develop the whole thing from the ground, including them. So currently, we are done with the app and we are in a process of training the farmers to use the app. We understand that some of the farmers do not have mobile phones. Others too, they have mobile phones that are not smartphones. So to also cater for that, we have we are talking about this concept of e-kiosk, where we maintain one person in the community as a pilot project for maybe 3 months, where the person will be given internet access in a mobile phone, and then will be made to integrate with the community. Those farmers who have diseases in their farms and they don't have phones or they can't use the app, they are at liberty to bring samples to the house and give it to the person at the e-kiosk to detect for them. They can also take or talk to the e-kiosk attendant, who can also go to their farms and also use the phone to detect their diseases for them. We are already in talks with NGOs and then Ministry of Agriculture. Then we are talking to some of the district assemblies and then corporate organizations like the telecommunication providers, for instance, MTN and Vodafone, so that after this phase, they would, if they are willing to help us, to support us to maintain the e-kiosk concept for a period of time and see how we can manage it for that period of time. The second aspect is we're also looking at self-funding. So when I talk about self-funding, what I'm trying to talk about is that if we are able to do it very well, we will be able to maybe introduce a concept where a farmer, any farmer who looks for the services of the e-kiosk will pay a token. For instance, maybe 1 CD or 5 Ghana CD. Even though I know the farmers are not, like, I don't want to use the word poor, but they are not that well to do. But again, if the farmers get to know the advantage or the advantages of this app, then asking them to donate that kind of a token for the services of the e-kiosk would, I don't think, would be a big problem. The roles of the community members, especially the female and the disabled, what we expect of them is to fully get involved in this project. That is why we started with them by going to them and then seeking their opinion and then their experiences before we started the whole project. Now we expect that the females and then the disabled would actually use this app to improve their crop yield and to serve as a motivation for the young ones, the young females who actually do not have interest in farming. The second thing is adoption of technology so that they can know that the technology can improve farming instead of relying on the pass on traditions from their ancestors, which at times they work, but in most cases, when the weather fails, those pass on traditions do not work. Looking at stakeholders like Ministry of Agriculture. So when you come to Ghana, it is this ministry that coordinates the activities of all farmers in the country. So it is very relevant that we engage them, ask them to help in diverse ways. So for instance, there are situations where you might need a farmers to do something. It may be difficult for us as research groups to organize them, but the ministries have been doing this for a long time and would be able to help to make it something that will not be difficult for us. At least it also applies to all the other organizations, the district assemblies, and then the NGOs that we have. Luckily for us, we have two partner. We have one partner NGO and one SME. And the partner NGO has been dealing with farmers in the northern part of the country, and they have a wealth of experience that is helping us a lot. In fact, in organizing the stakeholder training and then all the phases that involve organization of the farmers. The SME too has also been working, trying to introduce technology to rural communities, and their contribution has also been very vital. What we expect is that if the farmers adopt our technology, it will improve yield for them, and then indirectly the finances will go up. Again, as I said earlier, it also help them to be able to adopt technology, because naturally in this part of the world, you will notice that when there's a new technology, the male adopt it earlier and faster than the females. So we're also trying to bridge this gap so that they can also be technology adopters at the early stages. Thank you.